All right, this is the test review for Module 5, which is going to look at two things, exponents and radicals. So let's take a quick look at some of the key skills we're going to need for this exponents test. So all the way back in lesson 5.1, we looked at when we multiply things together, that we add the exponents together. Remembering if we don't see an exponent, that means it's an exponent of 1. That's why 7 plus 1 is 8. Or when we're dividing, we're going to subtract the exponents. Be careful, particularly when there's one negative here. So you're doing 5, subtract -2. So be careful with things like that. And use those Desmos calculators when you're doing those negative numbers as well. This one's also a divide, so that means we're going to subtract the exponents. 2 take away 8 is -6. But in lesson 5.2, we showed that you can't have a negative exponent in your answer. So we do that move and change. We move it from the top of the fraction to the bottom of the fraction and make it positive. We have to have something at the top here, so we put a 1. Remember, x is also the same as 1x. That's kind of why the 1 stays at the top of this fraction as well. And then a combination of this, 0 exponents mean that the answer is 1. So this here, you can see here, is 1. So when you times it by -5, it's -5. So it's almost like you're crossing this out. And this time, my negative exponent is on the bottom. So move and change, move it to the top of the fraction and make it positive. And then we have this answer here. Just be careful with the idea of moving things that are negative from top to bottom. It's only exponents that we're doing that for. So -5 is not an exponent. That's why we don't move it. But down here, the -2, that is an exponent. That's why we do the move and change at that part. Power to a power rule, big clue for this is you're going to see the parentheses here. When you have an exponent on the inside and an exponent on the outside, you're going to multiply those exponents together. 2 times -4 is -8. Same thing, you can't leave that as your answer. Change, that's why you get 1 over 8, x to the 8. And if you have a problem that has more than one term inside the parentheses, it's kind of like the distributive rule. You'd do a to the power of b and then x to the power of b. Or more likely, you're going to see a question that looks like this. So you'd do 5 to the power of 2 and m cubed to the power of 2. And then you just work out each one. 5 squared is Desmos. 3 times 2 is 6 using your power to the power rule. And if we get a question that's a little bit longer like this, put each of these pieces to the power of 4 and then work out each one. 3 to the power of 4 on your calculator is 81. 5 times 4 is 20 using the power to a power rule. And -2 times 4 is -8, also using that same rule. And then that negative exponent, you can't leave it. So move and change, and that will give you this answer here. And if you have questions that have fractions in, just remember to kind of work out the top, work out the bottom, and then simplify. So on the top, I can see they're next to each other, which means multiply, which says I'm going to add the exponents together. So 17 add -8 is -9. Oops, that is supposed to say -9 there. I do need to fix that. And on the bottom, this is power to power. 4 times -3 is -12. And then as it's a division question, I would subtract the exponents. So this is supposed to be, oh no, that is 9, not -9. I apologize. I can see it says 9 here. 9 take away -12 does give us 21. And that would be the correct answer. And if we were to get a question like this, it's very unlikely, but in case you would split the top one into parts with an exponent of -3, you split the bottom one into the parts with -1, work out each one individually, and then same thing. Do the division right at the end of the question. We're not going to have that on our test because that's not the most typical type per question. But if they want to be particularly mean on the SOL, they could potentially ask something like that. So let's start off with our exponents review then, and let's have a look at the type of question we're going to get. So our first style of question is going to be that thing with an exponent on the outside, and remembering that we've got to do like the distributive rule. We've got to do 9 to this power, x squared to this power, and y to the -5 to this power. So to speed things up, I've already written those parts out, and I've also used Desmos to help me as well. So 9 to the -2 is 1 over 81. And as I'm doing this as well, you can also notice as you look at the answers, some of these answers don't even have an 81 on the bottom of the fraction here. So I already know it's between A and B here. 2 times -2 is -4, using the power to power. And -5 times -2 is +10. And I can already see the correct answer is going to be A because it's the only one that has a y to the 10 and an 81 on the bottom. That negative exponent, remember, you're going to do a move and change. So that's going to move to the bottom of the fraction like it does here. And if you want a little bit more convincing, you can actually look at this step here. But for some reason, the 81 is missing here. That will be a little bit of a typo. All right, question two. I always think this is one that people struggle on. The one where you have a power to a power question, where you have something with a parentheses and an exponent on the outside, and then one term that doesn't have an exponent on the outside. Technically, it's a one, but we don't need to write that. So the only thing that we're splitting into pieces is this part here. So 2 to the power of 6, x to the power of 6, y to the power of 5 to the 6. This term here, we're not doing anything with that at all because there's no exponent on the outside. 2 to the power of 6 is Desmos, and it's 64. X to the power of 6, as there's only one exponent here, that is just x to the power of 6. Power to a power, 5 times 6 is 30. And then I got to multiply it by this term here. And I'm going to go to the next slide because that's already written out a little easier to do. And then we've got to keep going because we have like terms here that we're multiplying because these things are next to each other. So 64 times by negative 4 is negative 256. When I'm multiplying, I'm adding like exponents together. So 6 add 2 is 8. No exponent is 1. So 30 add 1 is 31. And hopefully from there, we'd be able to pick out what is the correct answer. And there we go. Question 3. All right, so our fraction questions, this is the way we want to work out the top, work out the bottom, and then we can go ahead and simplify. Let me see if I start to write this one out. Yep, I did. So I got the power on the inside, power on the outside. So I know I'm multiplying those together. So negative 2 times 5 is negative 10. 4 times negative 2 is negative 8. And then I can start simplifying this fraction now. So 3 divided by 21. That I didn't actually add on to the calculator. So let me just quickly do that one. Using the fraction button, you can see that it's 1 over 7, which is what we have here. And on the other side of things, negative 10 take away negative 8 was negative 2. And then that negative exponent, move and change, bring it to the bottom, and then you can pick out the correct answer. Now, for this question, there is more than one way of doing this question. On our test, we'll probably do something where we have, not everything's going to be multiple choice. We are going to have some drag and drop questions as well. So just in case people are finding little cheats to answering these questions, this will guarantee that people know how to do this correctly. You can simplify this first and then do it to the power of 3, but then you've got to remember which methods to use for each question. So what I would prefer people to do is this. I would prefer them to say, I'm going to do 12 to the power of 3, x to the 5 to the power of 3. So everything on the top of the fraction to the power of 3, and then everything on the bottom of the fraction to the power of 3. 12 to the power of 3, we're just using Desmos, 1728. 5 times 3 is 15. 3 to the power of 3 is 27. And then x to the 3 is just x to the 3. And although these numbers are big, remember we're using Desmos, so it doesn't make any difference. We're going to get 64. And then our rule for exponents when we divide is we subtract. 15 take away 3 is 12. That means we're only using one different method. Now, if you can understand this next method, this is quicker, but then it means you've got two different methods to remember. If you simplify first, 12 divided by 3 is 4. 5 take away 1 gives you 4. And then when you come to split this up, it would just be 4 to the power of 3, x to the power of 4 to the power of 3. 4 to the power of 3 is 64. 4 times 3 is 12. And it is indeed the same answer, but you can see that there's a lot less working out here, but it's an extra method to remember. There is one for you to practice, and you could always pause the video and try this question and come back to it. And actually, I didn't have the answer there for this one. So let me see if I can quickly work this one out. This would be 64 a to the power of 24. And if you see where that is, then it means you understand this question. Now, we do have some word problems as well. So area is a common question they like to ask when you want to multiply these two sides together. They will give you the formula for area on the SOL, so we will on the test too. You're going to multiply these two together. So numbers first, 3 times 6 is 18, and then x times x to the 8, no exponent, so it's 1, and then 1 add 8 will give me 9, because I'm adding exponents when I multiply. So the word problems are actually a little quicker. The area of a square can be found using this formula, s squared. Find the area of a square with side length 9v to the 8, w to the 3. Now, I drew a picture because I just find it helps me to do this. There's one side. Obviously, if it's a square, this is going to be the same length. And then from here, I can just say I'm multiplying like I did on the rectangle. 9 times 9 is 81. When I multiply, I add exponents. So 8 add 8 is 16. And 3 add 3 is 6. Or if you prefer, you can use that formula, write out what the side length is and square it. Split this into little pieces like we've done earlier, and then work out each of the pieces. You get the same answer. I think some people prefer one method and some people prefer another method. All right, going on to radicals. We obviously know there will be some multiple choice, but wherever possible, we try and want to not use the multiple choice method. So let me move my picture out of the way here so we can work on this question. So the first thing is we want to type in the question. If it's a whole number, then that's the answer to the question straight away. This time it's not. Now, this is really where I want to go full screen if I can, but it's not easy to see. All right, I'm going to have to leave it like this because unfortunately that's blocking my access right now. So we click on the plus up here, click on table, and then this is the method that we have to learn. You delete Y1 and you replace it with the number in the question, which is 147, divided by x1 squared. Now you can use the square button down here. That's perfectly good. And one of the other reasons for typing this question is this tells you where to start your table from. So this says 12.12. So I start from the number 12. What I'm looking for here is to get two whole numbers, as in this I do not want as a decimal. If I do get a decimal, that means it's not the correct answer, and we're just going to count down. So 11. Once you've typed in two numbers, you can just click enter, and Desmos knows you're counting down in one. 10, 9, 8, 7, and that's where I'm stopping. As soon as I see two whole numbers here, I know that means the answer to the question is 7 square root of 3. Let's just make sure it is. Now, the other reason, and I don't really need to check this one here because Desmos can actually check for me. Once you think you have the answer, you should type in what you think the answer is. So notice this is 12.12. Remember, originally we also had 12.12. That's a good way of checking your answer at the end of a question to see if it's the correct answer or not. And you can see the full table here as well. I did get 7 and 3 earlier. And as you're plotting it, you'll often see like this little curve shape as well. And that'll be a good indicator that you're doing the question correctly. If you get multiple choice, and we don't really want to rely on that because we don't need it, but if we do get multiple choice and we forget that method, we can fall back and type in the question, type in each of the answers, and then find the one that's the same decimal. So 12.12. And then we've got our answer there. The problem occurs sometimes, though, we get two answers that have the same decimal, and then we've got to make sure we know how to do that. So if we can use the table method, that will make this much easier. All right, this time I'm doing the cube root. So to enter cube roots, you press functions, scroll all the way to the bottom. And although this has a comma in, we do not type in the comma. Otherwise, Desmos will think we're actually doing a coordinate. So I just type in 6,000 without the comma, 18.17. Unfortunately, it's not a whole number, which means I have to keep working. So same thing as before, plus table, delete this number, replace it with the number in the question, 6,000 divided by x1. Now, on the last question, I divided by x1 squared because it was a squared number. On this question, I'm going to divide by x1 cubed. Now, I press Shift and 6 to get the exponent. You can also use the A to the power of B button as well. And just like the last question, I'm going to start from whatever this answer is here. So as this said 18, I'm going to start from 18. I'm going to type in 17, and I still haven't got two whole numbers, so I'm just going to count down until I do. 10 and 6. And as we're typing in our answer, just remember to not put the square root, but to put the actual cube root for this one. So there's that symbol. 10 times the cube root of 6. And if we check our answer, we should be good. Notice the 10 cube root of 6 is 18.17. Notice we had 18.17 here, so we could be pretty confident that we have the right answer for that question. And there was the table, just so you could see a little clearer with the 10 already entered. This is the reverse radicals question, where basically they've told us the answer. We've got to figure out what the question is. Now, the rules for these ones are basically we don't want any number in front of the radical. So when that happens, we want to move it inside the radical. And the way that we do it is we're going to multiply it by this number we bring to the inside. And as this is a cube root question, we're going to cube it. If it's a square root question, we're going to square this number. Now, as I'm typing this in, all I'm actually typing in is what goes inside the square root. So 2 times by 5 cubed is 250. Notice I didn't type the square root. So the answer to this question should be the square root of 250. And apparently that's not right. Apparently I have an error and I need to fix that. But 250. Did I type the right number there? Yeah, the answer is definitely 250. I have it typed in. I have the coding incorrect. I will make sure I fix that. Now, the reason I know that that is incorrect is, or the coding is incorrect. If I actually type in the cube root of 250, I get 6.2. No, oh, well, I typed in square root. Having said earlier, make sure you type in the right root. I did not type in the right root. So let me try again. Let me try typing in the cube root of 250. There we go. Notice 6.29. And the original value I had when if I type in the original question, which I haven't done actually yet either, 5 times the cube root of 2. Notice is also 6.29. So you have a good mechanism for checking answers on tests, even if your teacher's not actually there or is able to answer those questions for you. And there you can see this one a little bit better now. And if this is a multiple choice test, you can type in the question and each of the answers and find the one that has the same decimal value, and there's nothing wrong with doing that. All right, combining like terms, when we have square roots of 3, we're just looking at the coefficients. So 11 take away 5 is 6. So the answer is just 6 square root of 3. Kind of like if you did 11x minus 5x, it would just be 6x. You should type in the question and you should type in your answer and make sure they're the same decimal. That will ensure that you pick out the right answer. Now, on ones like this, we can't just add these together. I certainly can't say 45 add 5. That's not going to work. So I would need to simplify the square root of 45 first. Now, if I type it in, you can see that it is a decimal. So I'm going to need my table method. I'm going to replace y1 with 45 divided by x1. And I'm using squared this time because it's a square root. And I'm going to start from whatever this number was here, 6. Even though it says 6.7, you don't need to round up. 6, 5, 4, 3. There we go. We're done. 5. So this is 3 and 5. So I have negative 3 at the start. But instead of writing down the square root of 45, I'm going to write it like this. 3 square root of 5. And the reason I'm doing this is, if we're adding and subtracting, we must have like radicals. And if we do not, then we have to write them such that they are like radicals. And I'm going to put the 1 here as well at this stage, just to remind myself that it's not 0 square root of 5, it's really 1 square root of 5. And as I'm multiplying here, like terms, negative 3 times 3 is negative 9. So I got negative 9 square root of 5 plus 1 square root of 5. But notice now it's like the previous question. The numbers are, or the radicals, I should say, are the same. So all I'm doing is I'm just adding the coefficients. So negative 9 add 1 is negative 8, and then I can select that answer. If we're being really sensible, we would type in this question, we would type in this answer, and just check that they are the same decimal as well. And you can see that answer just that little bit clearer. Whoops, looks like I forgot to change the question here as I was working it out. That's the previous question. Whoops. Oh, I'm sorry. There's the answer to one of the questions, and there's the answer to the second one. I think the number came up incorrectly as I was working that part out there. And on the last question, this one's the simplest one of all. 3 times 8 is 24. 7 times 2 is 14. You should check to see if square root of 14 simplifies. It does not, and that is the correct answer. And that is our last question. 6 questions on exponents, 6 questions on radicals. The radicals questions are the easiest. And the last one as well, I should type in the question and make sure that I get 89.79 as well. And if I don't, then I can go ahead and fix it.